Alright, hello everybody. Today, I don't know how's the audio. I hope it's great. But today, say something Marinho just so I can track here.
Something Maria just so I can track here.
Okay, thank you for being literal.
Yeah.
Alright, so let's go. I have the code here, and last session, we basically had a design session, right? So, off the recording time, I basically took some time to write a generic sort of Merkle tree. It's not really like everything we would need, but I basically wrote what I envisioned of what would be necessary to get us off the ground. So let me explain this code real quick here. So I basically defined a functor that receives another structure inside of it. So it is receiving a structure name that I'm naming here as data that has this signature. That means it needs to have a type for the content and a type for the hash. And two functions, one for hashing the contents to hash the leaves of the data, and one to hash the hashes, so we can basically cascade build the tree from the bottom up, right? So raise the tree from the ground. And then with that, we have this data structure that is basically an empty tree when it is a node, which assumes a binary tree, by the way. A better way to do it would be to kind of do the iterative algorithm that I was working on. But, well, that's not done. There's still quite a few bugs there, so let's go with this. By the way, sorry for the viewers, but on coffee today. So, and then we're gonna have a hash that will have the same type of the data that we have. So this gives us some freedom to basically assign whatever the type we want here and do as complex as we want the hash to be, but still maintain the same hierarchy of things, right? So that's great. And then the leaves, they're going to be the only ones that have the actual content, and they're going to have the hash. If we want to make the tree generic, I think the best approach would be to make a list of children here, right? Call this like a little children. And then we have a list of t, and then here the logic in the generic case would slightly change. So right now it relies on recursion, and it's a very bad recursion, I gotta say. But basically, we're pattern matching, and when we do this, SML has top-level pattern matching. So this is pattern matching the function name with this argument. It produces this. If it pattern matches this function with this, then it produces this. So you read it like that. So if the list is empty of the attributes we're getting, so the content list. So imagine in our case it would be the actual things of the blocks of the file, right, that are split. So you write the file goes to the disk, and then let's suppose each chunk gets separated in 1 byte, and then you're gonna have A, B, and C, whatever, and then you're basically sorry, you're separating those parts, and then it's gonna be fine because it's gonna enter on this. But if it's empty, we're just gonna give an empty list. If we just have one guy, so we can only extract the head, but the tail is empty, we know it's a leaf node, so we store the content and hash the content. If we have more than that, then we receive just the list, and then we pick the left and right. And I know this is garbage, but since the tree is binary, I'm assuming an even division. So I'm basically dividing things, shoving one to the side if I need to, or just keeping an even split between the left and right contents, so we can agglutinate the list. And then we basically build the thing with this pattern matching. And it's quite sad because SML doesn't have a lot of sugar syntax that you have in other ML languages. For example, all the attributes here, they are the same type and they produce the same branch, right? So in, for example, F#, you could do this. So that eliminates a lot of the boilerplate because you could just access the thing here, right? And then if it falls on this branch, it immediately goes here. So it understands that. There might be a way to aggregate them, but I'm not sure how to do it. So I basically did the possibilities with this, right? I discriminated all of them so we can actually see, and if we mutate this, we can actually maintain the code. It's better than just putting a wildcard here. And then we don't know what.
Yeah, wildcards, they tend to break when you change the code around them.
Yeah, it's terrible because you don't know where you need to change, right? It will not break. It will just silently break. Just see here. Just give me a sec. Okay. Okay, so this is the tree. Now, how to use it, right? Let me see. Can I? Okay, it's breaking using Visual Studio. Okay. So this long as line here, we could assign this to a thing, but well, let's do that. So this guy, what? Okay. So structure ABC, I don't know what I will name it as. This is what? Oh, this is the hashable. So that's what I'm calling it. Very creative, I know. So this is basically just this. There we go. And then hashable. So let me explain. We're making a structure with this hashable that has the hash as a string, the content as an integer, the hash content it converts to a string, and don't mind this, is just that it doesn't know where this is from, but since we're using poly, this exists. And then the hash hash picks two hashes and then just concats. This is concatenating a string, okay? By the way, this operator exists in F#, but it's deprecated for some reason. Because people want to make it look like it's overloaded on the plus now.
That's terrible.
Yes, I hate it. Because people want to make it look like Python, and you can even make a statement on this case, right? But when you start to change the structure of the language to adapt foreign ideas just for it to look friendly, it's misleading, to say the least. For example, Latin, right? So in F# you can make a function like this, f, and then it picks an argument. Well, let me put, yeah, okay. And then you do let y oops, something like this. So in OCaml, this would be the same thing, right? So you have basically this. So like what it means is that it's binding a function that, by the way, it's the same because it's actually just a lambda, right? This is just a lambda.
Right.
If you think of the identity monad, the identity monad is literally just carrying identity bindings over them. And what are the identity bindings? They're just like delayed lambdas, right? With a thingy, and then they give you the thing, right?
Yeah, it's how you can implement, in some scheme dialects, let is actually a macro that expands to a lambda that's immediately called.
Yeah,
Kind of like that.
yeah, that's exactly the identity monad, right? So and that gives you freedom to implement, like in Scheme, for example, that you can expand macros, right? You can just change the underlying function, right, to do this bind, and then you can have optionals, you can have all the sorts of crazy stuff you want. And it's the same way here. So it's not the same, categorically speaking, it's not the same as Python's assignment, right? It's totally not the same.
Right.
So, or even JavaScript's let or whatever. So to name it the same and just omit this in, it makes it like seem like it's just a loose expression, right? And perhaps that's the invitation. But when you are thinking of the monads, then you start to think this is the actual expression. This is just a binding for this expression, for the subsequent expression. The same way that you might have another one, right? So even this is not being used, this binding is a subsequent binding for this other binding, which in turn is a subsequent binding for this guy. Yeah. Subsequent. I said the wrong word.
The problem was just that the in is indenting the expression a little bit. You could just put it on the upper line, right? Like
Yeah, you can do this.
Yeah.
You can do this. In OCaml they still are required, and I hope they keep it that way. But in F# they made the decision to remove it because, well, you had to explain to people, and I think that's not friendly. But I think it's worse to let people do stuff like this. Like, I don't know, if you put an expression, let's suppose you're calling a function here that does a side effect, right? Func1, whatever. So it's gonna do a side effect, whatever. But it also returns a value. In like C, this would be fine, right? It ignores the value by default.
Yeah.
Here it will complain because you need to pipe it to an ignore. Because the ignore, if you look at the signature, it will be a function that picks anything and sends it to unit. So why unit? Like, why does it matter to be unit in the middle? And the answer for that it's because it's a neutral binding on the scope of the binding monad, right?
Right.
The identity monad. But anyway, like these are, by the way, a few things that I was writing on that Why Syntax Matter article and talk that I was going to take, but I didn't progress on this.
Yeah, just to make a little addendum here. I don't mind having different syntax for string concatenation, but I don't like having plus specifically for that because additional numbers is commutative, but string concatenation is not.
So that's exactly my point. Like, it could be an emoji here. I don't mind. I mean, it could be a bother typing the emoji, right?
Yeah.
But I don't really mind about what is the symbol you're gonna use, so long as the symbology is representing, when it needs to represent different things, it represents different categorical things. So for example, what you mentioned, to use the same overloaded symbol, in this case they are being overloaded, sure, the plus, because of the concatenative value, right, of it. But in mathematical terms, that's not the same thing as a list terms. We know that it's handling as a monoid. Just a sec.
Yeah, it's handling as a monoid.
We know it's handling on a monoid on the integers in with a function plus, right? We know we have a function concat or whatever. So we know that, but it's still like, and we have a neutral element, whatever. But that's still not the same thing when you start to expand to other attributes of it, right?
Yeah, because, yeah, sure, string concatenation is also a monoid, but number addition is It's a monoid, yes, but it's
Mhm.
also commutative. That's a property that
Exactly.
string concatenation doesn't have. So using
Exactly.
the same symbol there doesn't make much sense in my mind.
I totally agree. So anyway, that's the thing. So this module is the hashable, and then we just feed it on the Merkle tree. By the way, we need parentheses here. So yeah, syntax quirk. So then we have now an instance of our module of our functor applied on this tree, and then we can call this stuff. So build the tree, and then I just pass a list. I'm passing on purpose an even list so we can see. To run, I think I will have to do this here. Can I comment on this trash? Oh, I can. Interesting how I say trash for everything. Okay, so like this. macOS, kill me. Poly?
Oh boy.
If this works, that's it, money. Oops, I think I need to do one at a time. Please don't ask me again. Don't try to be safe with me. Okay, so now if we do, there we go, so we can see the tree, and well, we're printing, so let's look at the hash. So this is how we split, right? So it will be, just give me a sec,
A question.
Okay, let me just resume. Okay, it's recording again. What is it?
Magenta, I have a question. Why is the 5 between the 2 and the 3?
I want to know that too. So let's see. It will first split, right? So it will be, this is a, oh, actually, it will do this, actually. Right, so it will split with this, go to the left, this goes to the right. Then the hash will be, okay, split this again, but, well, again, this is a uneven, so 5 again. Oh, so maybe my Lisp code was actually not incorrect.
Yeah, if you look at the chat, I actually posted a commented and slightly changed version of that because I was playing around with it while waiting for you.
Okay, that makes sense. Okay, so let's continue. So now it's even, and we can split in pairs, right, for each branch of the tree. The same way will happen here. So we're gonna split, and it's gonna be 3. And now we can compose, and then it's gonna be 1, 2. So this should be the final hash, I assume. So, which is definitely not what is here. 1, 2, 5, 3, 4. That's weird.
Yeah, it's very mysterious.
Yeah, because both were, I mean, this is a special case for the scenario where we have odd numbers, right? Because if we do for even numbers, it will
By
probably
the
work.
way, I really don't think that duplicating things is ideal when we have odd numbers because then we'll have a lot of gratuitous hash collisions when we switch to actual hashes here. Because like, if you have a file 123 and you have another file 1233,
Right, I see.
yeah,
But what's the alternative? Let's see. By the way, why is it flipping the order? On the right, it's flipping the order, right? It's 3. So, oh, because 3 goes to the right. But why is 4 going to the left? I don't get it.
I don't get it either.
I mean, I'm not flipping here, so... Okay, yeah, maybe... But I see, I agree. This is a problem indeed. So, modifications to change. Let's make a to-do list here. Thank you. So, change... actually...
Oh, why is there a reverse on the right side in lines 17 and 19?
Oh, I remember doing this, yes. Here, right? So...
Yeah, there and 2 lines up as well.
Yeah, so the point of this reverse, as I was imagining, was that we're gonna have to, like, I didn't have a split function, like a split by this position and give me 2 lists. So I'm literally using take, but I reverse. You see?
Oh,
That's why. That's why it's going inverted, right? Because I'm picking the things in order, so I would have to reverse again after the... I mean, this matters nothing, I think, for the hash generation. Does it?
wait a second. ML doesn't have drop in the standard library?
Oh, that's well, I didn't search by drop, the name drop. Let's see. It does. Okay. Okay, but that's mutating the... I mean, not mutating, right? I would just have to assign... that's cursed.
Well, no, it takes a list.
Yes,
Takes a
it
number.
takes a list, a number, and then it gives me a new list. But I have to modify the new list, right? Or reassign, like bind again, do shadowing, or assign to another variable. That's my point. Man, one thing I really dislike is how unpolished the syntax can get. Because, for example, here, we are inside the let val, and then we have this the body, and then this is the, well, sorry, the bindings, right? So this is all going here, and this is the thing. You end up doing most of the bulk of the code in here. Because the incentive is for you to do the separation between the logic and here, right? And the bindings. So they are dissociated. That is great, but if you need to do interdependencies, like for example in like in Lisp with let star, let's say, you only have things in order because you don't have like let recursives. I don't think so. Oh man, my voice is running out. I don't think you have recursive lets. No. So that's one of the problems. But I can't speak, man. Okay, let's... So the problem to solve here is... Don't know if we should be solving this though. I'll do this, Marinho. I'll mark these things here, and then we're gonna fix this, because for the purposes of what I wanted to do, this already does it, so we can continue, although it's wrong.
Okay.
Make 3 non-binary. That's one. The second would be...
Use drop instead of take and reverse.
Use drop instead of take and reverse.
And can I add a third note? You can actually get rid of that if you can just say build tree, whatever, and then where you have a +1 in the else branch, you can just have plus length mod 2, and that will be the same thing. You don't need to duplicate the entire expression.
Right, length mod 2.
Hello, Lemos.
But here's the thing, we shouldn't copy, should we? Like we're duplicating the last one.
Yeah. We shouldn't. We really shouldn't.
What is this party about?
Uh, I don't know. I just know that
Miracles.
I'm losing my voice slowly, but I am.
Marinho?
This party is about magic and miracles.
Yes, exactly. Let's go with that theory.
Magic and miracles.
I don't know what was the answer I gave. Somebody asked me something like that, and I said fairies, cocaine, and something else.
Okay, so maybe I should ask, what are you guys doing right now?
We're just revising the tree, like reviewing it.
Mhm.
We found some problems with it, um, and explaining the thing to Marinho, and we were reading before that. We were reading about the IPFS and the what was the
Gluster.
GNU Gluster.
Isn't Gluster like something like ZFS or whatever?
It's a GNU file system, a GNU distributed file system that does exactly the architecture we thought, which is like a bunch of synchronizing things, and then you have to coordinate all the data, and then you have these blocks accessing stuff. So it's
Mm.
basically the same thing, but they use XFS to actually store the data, which is like a binary tree access, whatever, blah blah blah, and then they just mediate the access there with two daemons, like the Gluster FS D. That daemon is basically the daemon that handles the access to the data, and the Gluster D is the daemon that synchronizes the information about where things are.
So they are basically our maps.
Yes, in this
Yeah.
case, yeah. So that
Mm.
was interesting to read, but that's it. That's what we did.
Okay, so what are the problems you found in the Merkle tree implementation?
So it's the first, it's binary, so we should make it generic. The second is that this code here should be using it's coming reversed because I forgot to reverse it again, and I didn't know that the list had a drop. So instead of doing this, I should just use drop, right? So I'm just gonna
Yeah.
replace it. And the last problem is the duplication, because we can't just simply pick and duplicate the last value, because that's probably gonna conflict with the, like when we hash, we're gonna hash the blocks, right? So
Mhm.
imagine you have 4. That's fine because you're gonna hash pairs, right? So you just hash one pair. Let me pick this example here. So 1, 2, 3, 4. That's fine. You can hash this, this, and this, and this, right? In pairs.
Yeah.
Think of a binary tree to help. If you have like a binary tree with like 5, things change, because now you need to extend this on the first iteration. You need to extend this, and now you can split into groups of 3 and 3. It's still even, right? This is overall length. When it comes here, you're gonna need to stretch it again and stretch it again. And when you do that, now you can split in pairs because you split in 4s in 2s, and then boom, you got it, right? So you split this. But just check the hash here.
Yeah,
What do you
let's
mean by checking the hash?
Like you're basically you're skewing the hash function, right? So it should, like, you're basically picking 3 and 3, 5 and 5 again instead of mixing it with 4. You're gonna mix it again on another layer, like the result of this will go with the result of this with
Mhm.
this, then the result of this with the result of this, and then the result is the node, the root, right?
Yeah. The problem
Mhm.
now is that suddenly the file 12345 will have a hash collision with the file 1233455, which is not ideal.
Yeah.
Wait, I didn't get that part.
So
Why
there's
are we
one,
gonna have
if there is
collision?
one file with this here, with this thing here, like these are hashes, correct?
Mhm.
So if we have another file with these hashes, it's gonna conflict. They're both gonna be semantically the same file.
Ah, okay. So what you're saying is that the strategy of expanding the things in order to fulfill the well, how would you call it, the structure,
Mm-hmm.
that will conflict if naturally we get this from first hand.
Yeah, this would be
Ah,
exactly the same as this, which is bad, to say
yeah.
the
So
least.
yeah, because of the expansion strategy, the second will be derived into into the former, and they will
Exactly.
be identical. So how in the balls do you solve that?
Don't know. No idea.
That's
Uh,
great.
I think I'll try to dig up a paper that I read a while ago that tries to solve precisely this problem, actually, of building a hash tree out of a sequence that may have arbitrary length.
Okay. So
Mm,
I'll put this
okay.
as a to do.
Yeah, we should put that as a to do.
I'll even leave the same here. I almost went JavaScript. I'm going crazy.
Yeah, I noticed that. Are we recording this or not?
We
Yeah.
are.
Okay.
So this way,
Yeah, pretty much.
cursed. Okay. So
Okay, but couldn't we? Well, I don't know how long you guys are going for.
uh,
Like, are you guys like 2 hours already?
30 minutes.
No, no, not in the recording, but in well, doing stuff.
Oh right. Well, I'm fine. I'm just losing my voice slowly, but I'm fine.
Yeah, okay. So shouldn't we try to make the
Yeah,
bookkeeper?
that's what I wanted to do. Like, this doesn't get in the way for us to implement the broker, the bookkeeper, right? So that's fine.
Okay, so let's do that then.
Let me just send a message here.
I have another question though. If you make the tree non-binary, do we actually need the expansions still?
Uh,
I don't think so.
we no, no, we don't.
Yeah, but it's so then it seems to me that the first to do addresses
The
the
problem
the
is
three.
the hash, right? Because the hash function should not take into account that it necessarily needs a pair. Then,
Yeah, but we need the pair
so
because
we
of the binary tree.
yes, but the point is you always need to merge the branches, right? So you
Right?
need to merge an arbitrary list here. That would be the only thing. But if it accounts for a single element, if it accounts for a list, it should account for a single element in a list by induction. So that should be fine, I think. The problem is because of the structure of the tree, right?
I don't know if I got it. Marinho, did you get it?
I'll try to rephrase. The problem comes from the structure of the tree that assumes that you always should have at least two. If you're handling a list by induction of handling an empty thing and then it comes blah 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 blah, then that assumes that you should handle an empty case, one case, two, three,
No,
four.
I
You see?
agree with that. I agree with that. But
So the
my
problem
thing
should
is
go
that
away, and probably with that.
yeah. So my feeling is that at the point that we make the first to do, I think the third one disappears.
And by the way, the Lisp code I was writing, I think that is right. Then, without, well, if we don't duplicate, right, on that, if we do it generic.
So maybe we could try to implement that in here.
Yeah, but anyway, let's concern for us of the future.
Sure.
So let's start with the brokeru. Brokeru, and we're gonna rename you to be bookkeeper.
So this struct will contain the Merkle tree and two maps. One for addressing locations, and the other one to address hashes, right, Marin?
Uh, yeah, basically we need to be able to say Uh, given the hash of a block of data, which nodes in the network have that hash,
Yeah.
the block that corresponds to that hash, and the other would be, okay, given a human readable file name, hash-wise, what does that correspond to?
Yeah. So let's make that struct. I think it's time.
I'm kind of reluctant to even name this a bookkeeper.
Hmm.
Let me think here. First of all, let's delete this, because this is not necessarily what we're going to do. These we're keeping it. Yeah, we are. At least for
Yeah.
now. Okay, so right, so let's continue here. So what do we want to achieve here? We want to do at least this, let's go for today to at least spawn.
That's a bookkeeper. It keeps the jump scares.
Boo keeper, yes.
That's bad. That's jeez.
Yeah, it's missing a K.
Let's leave it without okay for fun. I don't want to rename everything.
Okay, so we need to have some sort of record that contains three things.
Let me think here, man, of the thing. We need to, like, what would that be, right? That would be the thing that will have the map, right? So what we have inside of it? We have the map.
The other map and the Merkle tree.
Oh, by the way, we don't have maps. We have
Are
this
you
though.
joking?
We have a hash table.
table.
I think that
Okay.
works. So
I hope.
I think we can pass. Oops. I think it's just this. Oh no, wait. There is the string module. And I think this speaks probably a tuple. Undefined functor. So this is not a functor. What the heck is this then? Make table.
Ah. Interesting.
Okay, but then this is not a structure.
I think we need a record, Magit.
Wait, man. I wanna. I don't know what to store. Like, I wanna know what to store first.
Well, we need two hash tables and a Merkle tree.
So what will be on the first hash table?
That would be file name to hash.
Let's write that first then. So, what's on the first?
A mapping of a string to a hash. We should make a hash generic as well, so then we can change
File.
it later.
So theoretically, the file name, file name to
Hash.
which is the node, the root node of the Merkle tree.
Yeah.
Yeah, yeah.
The second
And then
is
there's another map that goes from hash to list of locations.
which is the hash for each block, right?
Yeah.
Right. Locations is whatever. And then we have the
Merkle tree.
Merkle tree. Right, I don't need to specify what it is. Okay. What are the operations that it should do?
You should be able to do lookups in both maps. So given a file name, you need to return like an option of a hash.
So let's think of like
File name lookup.
let's think of what to like the top level user operations, right? What they would want, the client operations, I mean. They would want to fetch a file, so read Well,
Oh, so you're talking about the the public API.
yeah.
Okay, so then
Open.
we need the operations that we define in the doc designs. Open the org file,
Did we
and there is a
define
pay.
that? Haha, it's not on this branch.
Now, awesome.
Let me see if I
But
can
there is a
remove
file
this.
in a branch that talks about what are the payload, and we should respect that payload basically.
Ah, the payload is just, we can infer that again. That's not a problem. But the operations like fopen, we need to first open the file and we would get what? We would get a file name.
Yeah, you provide a file name and then you return the payload, I think.
And then we return something. Okay. Well, for now, we can even do raise fail.
To do not yet implemented.
That. And then the F close. Not sure.
That's interesting. So you're assuming that the client will use us as a stream library or sorts.
I'm thinking if we
opens-
should do something like this because the whole point is for you to just open a descriptor, right, to get the file, like the chunks of the file and so on, right? Or to at
I was
least.
more imagining that you do by demand. You don't open a descriptor and have control over it. You just ask for the chunks and we give you.
Yes,
You
this is
don't
the
need
open.
to control us.
Oh,
No,
this is
no,
the
but
open.
when you have an API like fclose and fopen and fclose, it
No,
leads the
ignore
user
the
to
F
leave.
close. The F close, I don't know if we even need. That's what I'm questioning. But the F open, I think we do.
But why fopen instead of read?
You're not reading the content. You're reading the hashes. But why would you need the hashes? That's what I thought.
Oh, the hash is how you find the content.
Yeah, that was my idea. We only use the hashes for routing, Magit.
So the read, yeah, the hashes are how you find the content. But what I was thinking then is that the read would receive a hash instead. Because you're not gonna
Oh.
read. You're just gonna read based on an offset, which in our case is a hash, or on the beginning to the end, right, with a quantity.
Yeah, no, that he's correct, Marinho. I think the user needs to provide a hash because otherwise we're gonna always provide the entire file for it, right? Because how are we gonna know?
Oh, you need to provide the hash, right? But if you have a specific on the open, sending this descriptor, having already everything, then I think that's dividing the burden between two functions.
Marinho?
Yeah. Like, one thing is to say, okay, from the user's perspective, I want a file with this name. Another thing is to say, okay, this file corresponds to this hash, which means that actually we should open this thing here, which is identified by the hash, which is some arbitrary sequence of bytes that may not be human readable.
That's correct.
Wow, we're doing proper design.
Yeah, but let me ask a thing though, because what is the purpose of a user providing a file name if if I can't have the entire file, right? I want to read some data, right? That's cool. But let's suppose that this file has like distributedly like 5 petabytes.
Right.
How the heck are we gonna do that?
Oh,
I need you to provide you the hash.
You just get the hashes. You're not sending the content.
No, but the user is asking for the content.
Well, then you read all the hashes and then you get all the content and you string to the client.
No, but what if I don't want the entirety of the thing? Let's suppose that I'm doing a imaginary select with a where in SQL, right? So I'm doing that. I want the top 10 hits. according to whatever the query does?
Well, you need to read the data.
Well, not necessarily actually. If you're just doing a positional search, you may be able to
Yes,
see content.
yeah, I agree. But what Lemos asked, I think, is if you are actually looking at the content, right?
Well, in that
Yeah.
case, you have to read the data. There's no
Yeah,
getting
there's no
around
free
it.
lunch.
No, oh, okay, so then if I want to read the data, even though I have the hash of the correct location of this piece of data, to read the data,
No, wait. If you have the hash already, what's the problem? You just go there and you read that hash. There's no
No,
problem.
no, no. There's no problem. I'm just asking. Are we going to have two fopens, one based on the file name and another one based on the hash?
Well, if you have a hash, you know the file name.
Oh yeah, but this is the public API, so are we gonna have two fopens?
But the fopen is just done in the beginning. Why would you need to do it again? That's the read. That's not the fopen.
Ah, okay. Okay, so fopen is to create the file with this name.
The fopen is open a file descriptor for me. Like, give me the information so I can create a file descriptor on my client side, knowing where to edit. And
Okay,
then,
let's continue. I think I'm gonna get along the way.
like, this would return like this. Something like this. Hashes, something like this. There is a list of hash, let's say. And then it returns, I don't know, again the file name, string, and then it returns something else like last modified at, I don't know, string, time. Something like this, I don't know. Some random metadata, right? And then by returning this, I already have every information that I need to read, to write, update, whatever, right? Because I have the position of every piece of information. So if I need to, for example, read, right, a chunk, let's suppose that you are doing your duty with a arbitrary thing. In a file in a normal file system, you would have it on a line, right, in the disk. Or in a, not in a line, sorry, in a specific offset, right? You would calculate the offset and you got it. In our case, it's a hash, correct?
Correct.
So you go by the hash by looking at here. What is the hash that represents what I want? It's this here. You calculate on your client side and you say, okay, so I gotta pick this one. And then you go there and then you use the other function, which is the read. Let's define the read. So the read would be, should I name fread? I think that's, oh. I just did this because open is a damned, kill me. Can I do this?
Wow.
I can't.
How sad.
I have a question. So what will the hash list be representing again?
Wow.
Go on, Marin.
Well, there are two things that we can use this for. First of all, if the file is really large, and we change like 1 byte out of 5 petabytes, we don't want to have to hash the entire 5 petabytes again, right? That would be dumb. The 5 petabytes may not even be in the same machine to begin with.
Yes, that's true also.
Yeah, so instead we break up the file into chunks and then we hash each chunk and build a tree of hashes. And then if we change 1 byte, we just have to hash again the chunk that contains that byte, and then the parents all the way back to the root, and not have to touch the entire file of 5 petabytes.
No, I understand the gain in from the server side. What I don't really understand is what will the client do with this information?
Well, the other thing is, if I want to search for like the middle of something in the middle of a file, I can say, okay, give me the hashes, like the tree of hashes, and then I can just walk down the tree and skip the beginning of the file, not have to like do a sequential search. This is kind of like how closure vectors work. They are actually a tree of arrays. We can do something similar to like
Yeah, I
If we
really need an example to see the vision of this, because if I am a client and I'm opening a file, I do fopen, I get my list of hashes, I have a file name, and I have some metadata. I want to write stuff, right? I want to write stuff into this created file that I just created. I don't see how the list of hashes will help me at all to do that. So, Marinho, could you help me on this?
uh Wow, there are really two things that you could mean by writing. You could say, okay, I'm going to add data to the end of the file, or you could say, okay, I'm going to overwrite something in the middle somewhere, right?
Yeah, it's a recently created file, so there's no thing to overwrite. It's empty. I just created.
Well, in that case, you can just write the first chunk, and then that will be the first hash that you need to build up the file. Then write the next, and so on. Um, And then the tree is how you retrieve the data later. It actually doesn't really concern you all that much if you're just
Oh,
writing a
so
new
for writing, I
file.
don't use the hashes. I just use the hashes for reading.
Yeah, for if you're just appending data, you don't really care that much about the hashes.
Okay, so let's now go to the overriding case. So let's suppose I don't know the entirety of the data that I want to overwrite, correct? I just want to know that I want to change a column in my table, in my bracket tower listings.
Um, yeah, so if you know ahead of time, okay, given the length of each row and where in the row is the column that I want to change, um, you can calculate the offset into the file, right?
Yes,
Um, and then you
totally
can
doable.
say, yeah, and then you can say, okay, I need to go, um, I don't know, let's just say 5 MB into the file or something like that.
Yes.
So I'll grab the root of the Merkle tree, and then I'm
Mm-hmm.
gonna say, okay, given the size of each given how many bytes are in each branch of this Merkle tree, I will go to, let's say, the branch number 2 or whatever. Uh, and I do that recursively until I reach the leaves. And then I say, okay, here's the chunk, here's the bytes offset into that chunk. I'm going to write a new chunk with the new data. And then I'm going to say, okay, I need to rebuild the branch with this edited chunk, right? This new leaf.
Yes.
And then using this new branch, I'm going to say, okay, now the parent branch has a new branch, a new sub branch, a new child. So I'm going to rebuild that, and I do that going back to the root, and then I have the new Merkle tree for the edited file.
Yes. And then that you did all of that as a client, correct?
Well, the user of the file system actually probably shouldn't have to care about it.
No,
Um,
but he needs to, because he's the only one that can know the offset, because he's the only one with the relational stuff.
no, like it has the offset, okay, but then after that you'll just say, okay, I have this file, I have this offset, I have some data to insert at that offset. At
Yes.
this point, we actually don't need to know about the relational model at all. We already went past that.
Ah, okay, so you would send the offset, and then we would do all that stuff that you just said.
Yeah.
Ah, okay. So online shoe isn't type like a type alias, or am I going nuts, Magit?
Oh, what? Sorry.
I noticed that you made a descriptor with the keyword type online shoe. Is that how you make a record?
Yeah. Oh, by the way, records are tuples in SML.
Yeah, 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 but they are, well, field named tuples, right?
Mm-hmm.
They
So
are
then you
also
have a,
tuples in Haskell, if I recall correctly.
yeah, I believe so. So you have a create function that you provide the stuff and it creates the stuff. and then the fopen will just create you the payload. So you decided to keep the name payload on that. I guess it
As-
makes sense. We're gonna send this back to the user, so.
Yeah, these are. Oh, right. I think that's what we should name, right? Instead.
Yeah.
I was looking at how to make a hash table, and it's disgusting. Look at the signature. It's
So there
it's
is a.
profane.
Okay,
And
so let me try to understand what the heck is that signature.
Oh, and by the way, I forgot to mention, after we build the new Merkle tree, we say, okay, we just wrote the new data for this edited file. I have the file name, I have the new data, so I'm just going to atomically switch the file name to point to this new Merkle tree. And that's how you update a file.
Oh, so that we just changed the hash table. We don't need to do anything else.
Yeah, you just build a new file, a new like logical file. It's now identified by a new hash. So you just go to your table and say, okay, this name, it mapped to this other hash that was the old file before I wrote. Now this name will point to the new hash after I wrote the file. And
Yeah, but that
that's
sounds
like,
really bad because you're gonna have to garbage collect everybody that is with the wrong data now, right?
yeah, but you don't have to do it immediately.
I know, and we're not gonna do that right now. But in the future, when we make multiple bookkeepers and multiple nodes and broadcasting all that stuff, you're gonna have to implement some quote garbage collection to to make people do not contain the wrong data. How in the fuck are we gonna do that?
oh boy, this is. No, talk
I
about
mean,
this thing, man. It's disgusting.
Wait, can you explain why it's bad? I'm still not fully
So
convinced.
we need to this function. Ah, this signature, this apparently profane signature. It
Wait,
is okay. Go on.
is it? Can you remove the mouse for a moment, just for me to read the what LSP saying there?
Oh,
Okay, so it is a function that picks a value of some type A, returns a word, and you also need to return some sort of predicate that receives a tuple of those types and returns a boolean.
no, it's
From,
actually a function that
it's
takes a pair of two functions, one of which is a predicate.
yeah,
yes.
no, I didn't mention the first pair, but I think the second function is the comparison, Marinho.
Yeah, this is the comparison function. This is the God knows what.
Serialization?
And the last is
Oh,
the amount that I
oh,
think you're gonna start with. And
I think I know what it is actually. It's probably the hashing function that you wanna use in the hash table.
oh, makes sense. Oh, right. Yes, that's true. And then
Wait,
probably the amount that you're gonna start with on size, and the exception that you wanted to throw when you don't get it.
but if the first function is the hashing and the second is like the predicate for comparison, this is so underbaked then.
Well, look at what
Because
you have to do to just make it work. You need to assign now. They provide you with this stuff, right? So
oh, so you have a hash string function.
yeah,
Ah,
but
okay, at
it's
least that.
but then it complains that it's not generic enough, blah blah, because polymorphic expression cannot bind a polymorphic expression, blah 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 blah. And then the reason is because this guy here, right? So in a value, so you need to type it with a string, and then let's put word, whatever, word, like this, and then we need to put a hash table dot hash table. Voila.
Wait,
Cursed.
what?
Yeah, I just had to type basically because it was associating to a value something generic here. Right? So a
So
function it's
you're
fine.
making mono first. Ah,
Yeah,
what
I
is
know
the
it.
opposite of polymorphism?
Yes. So
Monomorphism.
Yeah.
thank you. Anyway, that's it. Not sure about the parameters here of the 42, but we can probably take a look later on this. Here's the problem. Should we set to the same hash and the same... We should, right?
What do you mean by the same hash?
Like, it should just store bytes and should just hash strings.
Yes.
Okay. So let's see.
Maybe it should be better to hash bytes though, because you're gonna receive the content as bytes, right?
If we are lucky to have hash.
That's not what we're actually hashing in this case, though. This is hashing the
Yeah.
keys of the table, which is the file names.
No. I know. But the value you see on line 17, there is a file. It's a map from a file name to a hash.
Oh wait,
And then the
there's
question is-
already a word hash table.
What should we be able to hash? And Mageta said strings. And yes,
Oh,
to
Much
some
better.
degree. Go away. That was great.
Okay, so I suppose this is the argument of the
The
response.
key?
Yeah, I think so.
We want strings to hashes of bytes. That's what we want. The keys should be strings, and the value should be hashes of bytes.
I'm not sure that the keys should be strings, to be honest. Oh, wait, this is the value.
No, but what do you mean? It's a file name. Well, what could that be?
Why?
aside
But
from-
well, I was doing this here. Oh, right. Okay, this right you're talking about. Okay, that's fine. But this, regardless, it would be pointers, right? Not a word. So. But well, it's not this anyway. It's still this. Let me just go back. Don't fool with SML. Can make your life miserable.
Okay, but here's the question: is this hash table that we are making here? What are the types of the keys?
String.
String. And what are the types of the values?
Word.
That's fine then.
It should be whatever type we are using for the hashes of the Merkle tree, actually.
That's true. We should use the same type.
So we
there.
should use word as well. So let me make a thing here called hash equals word.
Shouldn't we just make this somewhere centralized and just import in the other structures or something?
Mayhaps, but we're not gonna do it now.
Okay.
Furby.
So now you're gonna make the same thing but for hashes instead of files. And the key is gonna be hash, and the value is gonna be a list.
So this is where the fun starts. So so it lists of what? What would be the location?
The location I think should be a string in the beginning, like the ID of the node.
Oh, don't need it, I think.
I think it's incorrect because it's expecting a tuple. You're passing only a list of strings.
No, this doesn't expect a tuple.
Oh, you're changing to a word hash table. What is the difference between a hash table and a word hash table?
The word hash table, it just spits this here. So in this usage, it's understanding, like, it's a word, so I think the word is on the key, right? And then since, well, hashing bytes, I don't think that's gonna have any difference, right? Because in strings you can still hash it different ways.
Yes.
On words, they don't even allow you to tweak that, so
Yes.
You just use the word. I mean, you can still use whatever you want, but you need to implement yourself, right? In this case, it's already cooked, so let's just go with that. So there we go. Let me put in all
Hello,
caps.
Fernando.
Hello.
Hello, Fernando. I
Say
didn't
hi
see
to the
Fernando
future
join.
people who will watch this in the future.
And surprisingly, these people exist, which I'm still surprised.
You are not alone.
So the Merkle tree makes no sense for it to already preemptively. Funny, well, it makes no sense for it to exist because it's gonna be composed all the time, right? So we should have an instance of it, but not the tree in itself. So what we should use is essentially this guy here. Come here, my friend. There we go. And let me remove this trash because this is useless.
No.
Or
You
so I
what you
did.
removed is incorrect. Go back.
What the?
Remember?
Oh, this.
Yeah. Yeah. But we don't want the signature then. Are we gonna remove? Not gonna have a signature for that?
Well, we can add later, but why should we leave with nothing there? No.
I was thinking we would do like we did with data. You see lines
Like
42 and 43.
doing this, it's exposing nothing. Like we can't access anything here.
Yeah, no, but we're gonna make these functions now. So, but we can add it later.
Yeah, then that's fine. I'm just gonna keep it clean. I don't want this on my face. Okay, you go away. I don't know I copied you. So hashable stays here.
Line 16 and line 25 should be one of them is wrong.
Line 25.
And line 16.
What? Line 16. What do you mean?
Yeah.
Oh, here, word.
Yeah, we need to keep these things synced. The Merkle tree hash and the hash for the bookkeeper, these notions should be identical all the time.
Hashable. Hashable. We are going to receive a hashable. Since we're gonna make the tree, it only makes sense to import the tree.
Yeah, we should definitely make this sig a separate signature.
Stop abstracting, man. Stop abstracting.
You just copy paste in the same
Stop
crap all
abstracting,
the
man. I don't
time.
want to think, dude.
Perfect.
Okay, so this. Okay, this is wrong, right? So this should return. Well, I have another hash. So what we're gonna do for hashing hashes?
Just concat them and hash them again. I think that's the most reasonable for now.
Well, how do we hash bytes?
How do we hash files? Because files are just bytes.
Yeah.
So we should use like memd5, whatever. I'm just gonna
Do we have
concat.
that? Yeah,
Do we
just
have-
concat them from now. It's fine.
Yeah, it's easier said than done. Oh, we can convert to int, and then I can. But it might explode. I don't know which int I'll get.
Yeah, so I managed to dig up some very obscure papers that may be relevant to what we're doing.
Very obscure papers.
It's awesome to know. This, and then we do word from. Wait, there is a word from list. I didn't know about this. List of what, brother? Man, just. Oh no, this doesn't exist. You're fooling me.
Yeah, LSP trolled you hard.
You're fooling me. So how do I? There was a way. Wait, I have on my other project. I don't recall how to do this garbage. Yeah, man.
The bag of
This.
tricks of Baguette.
Wait a second. I do have it.
I believe it.
Postgres. There you go. Well, we could do an end with both, but that's not hashing, I suppose. Where's the bytes? I want to the thing that I use from list. From list. Nope. Oh man. Oh no, I'm not doing that. So, since this is just for testing purposes, you know what I will do, right, Lemus?
I think I have a guess.
There we go. We're gonna do a plus.
Okay, that's better than what I thought.
What did you think I was going to do?
Just keeping one.
Well, that would be certainly easier, but I would want to at
Hilarious.
least see changing, right?
Yeah.
Okay, let's keep it this way. I'm not overloading this. We can do this, by the way. Ta-da! No, we can't. And I don't. Okay, so I don't. Apparently, I don't remember the syntax. So whatever. So c'est la vie. It is that, and it's set in
No,
stone.
but that's fine because we already made the bookkeeper a functor now, so now the line 28 should disappear. And now we can make the first public function, I guess, right? For the bookkeeper that you should be able to call.
Just a sec. What I get pissed is that it doesn't show the. Should I rename this? Hashable is kind of a cringe name.
I think it's fine name.
Well, whatever.
I heard much worse.
Especially from me.
You,
Oh, I closed
no,
the file.
from Nathan.
Oh, Nathan doesn't name stuff. He doesn't even try, man.
He would call hashable as something that hashes. I'm sure, man.
Okay, so this is
I mean, it's a bookkeeper. It should keep boos, so why not call it boo?
Boo, like King Boo, right? Luigi mentioned. I don't know.
Yeah,
Isn't
like that.
booze
Exactly.
like an idiomatic expression for like beer and alcohol and stuff?
No, that's booze with
Yeah, booze.
ZE at the end.
Ah, I see.
So we better call Luigi here.
Who you gonna call?
Luigi.
Ghostbusters.
No, the answer was Luigi. That's who.
Right, because it's a boo, not a ghost.
Yeah, exactly. Let's rename this already.
I don't know, man. It's the same spirit of Wreck-It Tower. Wreck-It Tower doesn't have two T's.
Well, but it's a comic name, right? Not a wrong name. So bookkeeper. I kind
So
of
now let's make functions for the bookkeeper.
cringe about this. It should be this better.
We have a problem though.
And then this goes like
The
this.
files are
Yes, that's why I didn't want to change, because then we have to do this.
no, but the files are snake case and the variables.
Ah, who
names
cares?
are
The files.
camel case.
Who cares? Done.
A bad case for
As
the
long as
win.
just Lemus cares, I don't care. Okay,
Sure.
so oh right, this needs to convert into a hash. Let's type it. So, oh, conveniently, it's already a number, right? So from int, there we go.
I'll be
Awesome.
right back.
So we're gonna have a pointer there for like 1. That's it. Not dangerous at all.
Okay, now we're gonna make the we should make the public functions for the bookkeeper because you're gonna use this in your code, right? Well, we're gonna use it in our code.
Indeed. What should they be?
So I think this is the time to start understanding how to do networking stuff, like how to open.
Uh-huh. Which I can't do, by the way, because macOS. I'm using the REPL to test.
And you can't test the networking because of macOS.
Yes, so display my pain. Oh, okay. Now it's not compiling because of some poo-poo I did.
That's
What?
no, it's just not compiling at all.
26. What? And
Structure has not been declared.
what do you
Did you
mean?
save the file?
I did. What do you mean the structure has not been defined? You're here. Hash table. Found new files. What? Hashable. Structure.
I'm very confused.
Oh wait, structure hash table. So this guy has not been found. Oh no. Are you from here? If you're from here, I'm gonna become the Joker right now. You're not. Thank you. Where are you
Become
from
the
then?
Joker.
Hash table has not been defined, declared. What is the problem here?
So we need to find where the heck this comes from.
Let me see. Well, let me.
But that's kind of tricky because I thought LSP would only show the things that we have available.
I thought too. Yes.
Apparently, we cannot trust LSP.
Apparently not, which is quite inconvenient, I gotta say.
Okay, so in SML New Jersey they have it.
We can. Well, Polly does too. I see here. Just going.
So polyml.
Hash table. We can literally see the source code.
Oh yeah, no, but it is in the. There is a list of the structures provided by Poly. I have it in here. So do we have a hash table? Why is this not sorted?
Basis library from Polly.
And I'm back.
Tadaima.
Okay, there's only hash array in Poly.
Oh,
basis.
so PolyML doesn't have it. That's.
Awesome.
I wanna kill myself.
Please don't.
Oh,
Please
it
don't.
does have a hash array. Aren't you happy with that?
No.
You better be. Man, I hope the syntax is the same. I really am. The interface, I mean. Why do you
Which
do
interface?
this?
Do you mean like Melton or New Jersey?
No, the interface for the hash array, I hope it's the same as this hash table.
But are we gonna use a hash array instead of a hash
Man,
table
I find it
now?
funny because I've been using trash, but at work I usually use garbage, right? So you can see when the code is mine and when the code is Ben's because he uses trash, I use garbage. So he literally commit a branch named refactor trash on master today. So
I don't know. You should have said that to a recording, bro.
that's the truth.
Hilarious.
It's hash array. What is it?
It is hash array. Hash array dot.
It doesn't even show here. Look. That's.
Yeah. So LSP sucks. But the function is the following. Hash array.
Oh
hash
man,
array.
how do I make this?
Wait, are you not gonna list to me the functions? Provides a hash table type. Oh no, it is hash array, but it provides a hash table type and operations apparently.
Okay, but what is the interface to
But
create
it doesn't show me the interface.
No.
Why?
Like,
Why they do it like that?
Make a. Oh man. Pretty sure we can do this.
Poly.
We can't access everything, I suppose. Weak.
Poly, poly,
this is
poly,
a-
poly.
This is a place I don't think I should be. Internals. Something tells me that I shouldn't be here, but I am.
Man, it doesn't show me the
Oh man.
types and the functions.
I am inside the garbage collector, Lemus. What am I doing? I just want a hash table, man. Oh,
Holy
just give
Can
me a
we,
crap.
can we
sec. Just
check
give
the
me a
source
sec.
code
Just
though?
give me a
You said that
sec.
we could.
I'll pause it. Just give me a sec.
The hash that will be used for bookkeeping in the hash table.
Okay,
That-
I continue recording.
Yeah, I
Ah.
found it.
Okay.
So I'm reading the source code.
Oh man.
And the function to create from a hash array to create a hash table is called hash. And the argument that you need to provide is the size of the hash table, whatever that means. Okay, so creates a hash table of specified initial size. This version expands the hash table and rehashes when the table gets too full.
Mm-hmm.
That's what is written in the comment.
So
here.
is it just this?
Yes. It should be.
How? Okay, if I send like, and what state pad to push something to the hash table, to the hash
Is-
array, whatever.
That's a good question because I'm only seeing update, sub, and delete.
Awesome.
So let's see what update does.
Poly. Poly.
Okay,
poly,
update
poly.
just does update. Cool. And delete probably does deletion. Can we add stuff to this crap? That would be great.
Don't say crap. It's poly.
Oh wait, so you can Benevides can have the trash, you can have the garbage, but I can't have the crap.
No, you can't. Especially when it's poly. You need to treat it with respect.
All it's crap with an H at the end.
Man, how do you add stuff?
Maybe you're not supposed to.
No, what?
That would be funny.
Here's the link. Please, everybody, go into that and try to find the addition operation.
There we go. So we have X. And of course the REPL will not complete for me.
Of course not.
Hash array. What are the other functions that it has? Oh, maybe it's... Is it importing any signature? Maybe it does have that.
Importing signature.
Yeah, like a functor. Probably this is a
It's
functor.
updates, I think.
Update. Oh, that's
So
a...
an update is
crappy-
basically an upsert API then.
Yeah, it takes an A hash, a string, an A, and returns unit. It's actually a mutable hash table.
No.
So
So
let's
it is
see.
update then.
So it picks a tuple. It's actually a triplet. Just kill me.
Yeah, so you pass the hash, you pass the name, and you pass the value. And what is the return of update? It is
It's
unit, so
unit.
it is mutable.
So, well, whatever the hash is.
Oh yeah, it is in the line. It is in the code, line 112, Marinho.
And what
no,
is
that's
the
not
last?
gonna work because you need to the first member of the tuple is the hash. You need to create the hash first, then you put the key, then you put the value, Mageta.
Need to create the hash first.
Yeah.
Oh, I see. The type is the A hash. What the heck is a hash?
It is a parametric hash table apparently.
Okay, but that means that you should assign it somehow, right? Like the type. Like it's not.
Yeah, I
what's the
think
type
you need
definition?
gonna put in the type signature and it's gonna.
Oh, I did put a string here.
Okay, so you put X, then the key, then the value, and let's see what happens.
And then what's the last and the value?
Well, it's you put the first parameter of the tuple needs
All
to
right,
be the hash.
so-
So put X.
What? X?
Yeah, so you created a value X.
Oh,
with-
this is the
which
hash table. Never mind. I see.
Then you
so
put
this
the
is the
key, then
name.
you put the value.
I see. Well, let
So
me.
this should return unit, but then if you ask to print X, it should do stuff. Function update argument. Reason can't unify int with string. So some of it
Yeah.
should be.
So the typing here refers to the value. That's what I wanted to test.
Oh, okay. So. Ooh, that means that
Oh,
the
man, we're
keys also need to be always needs to be strings.
Yeah.
Okay, now ask to print x, assuming that there is a print functionality.
Well, there is. That's the only reason why I'm using this compiler. And because Poly is cute.
That's the only reason.
Oh. Oh, it's lowercase make string.
What?
It doesn't know how.
So you can't print.
Well, you
Okay,
need to
so
fold
let's
with
do
a print
let's
probably.
do a search. So how you search?
You don't. Oh, it's just called no
I think it's sub.
sub.
You do hasharray.sub.
Man, what a terrible name. Sub.
Judging based only on the type.
All
on the
names,
type
yes. I'm nominalist now.
no. Only based on the type signature.
Which is even worse, right? Oh, at least it gives me an option, so it doesn't explode
Yeah,
in my
it gives you an
face.
option. Yeah, but is it correct? ABC123?
Yeah.
Okay, so it did mutate it. Cool.
The
So
question
that's
is,
what we have.
is this still there? Because sub, I would expect it should subtract. No, it is there. Okay.
No, to subtract you do delete.
No, it's actually sub for subscript.
Oh man, what the heck? It's probably
But here's the thing. It has a fold operation. Could we use this for the Merkle tree?
yeah, we can. Because it's just we just need to reduce it to a list and then send it to the tree, right? Ah, poly.
crap.
Poly.
Anyway, but now let's change our the value files and the value hashes, and let's use this thing here. The problem is that we don't have control of the type of the key, which is less ideal.
The other problem is that the LSP doesn't understand it, so it's gonna be marking
Yeah, no,
as
but
errors.
we already passed that point a few minutes ago.
Well, the LSP also doesn't understand prints, by the way. Make strings actually.
Very like real programmers. You don't need LSP. We just need a compiler.
Okay, so I forgot for a second what to do.
Hash array dot hash, and then you're gonna make the first size, the initial size.
Let's put 10, whatever. We. And then all of these goes away, right?
Yeah, pretty much.
And
But
then
instead of a
just
string of a list of strings, you're gonna put
the content.
hash. Hashable dot hash.
What a garbage.
Yeah, no, but this at least we are saved from using lexicoscoping, right? Because we can use the same names because they are in different structures. Does this work? Can you try to compile?
Let's see, garbage. Delete this. And the hashable is fine too. So I can try compiling. It did compile. Okay.
What?
Yeah.
What is that?
Oh yeah, that's why I can't run. The linker for some reason is flamed because of my stupidity on ARM again, probably because of Clang.
Oh. Wait, but we were not having this problem before, so we're...
No, on macOS I ever did. Like, I always did. For some reason, since a few months ago, I always
when
did.
you ran... No, but when you ran before, we had some errors, right? Like, you could...
Oh no, yes, I can compile, it just can't link. So it is working.
Okay, so it is working. That's cool.
Oh,
so let's now make...
not working, it's compiling.
It's compiling. That's...
We don't know that.
Okay, so now let's make the functions that we're gonna call from the book.
Oh, by the way, this is this is this, right? It's a hash list.
No, it's a list of locations. It's not a list of hashes there.
Oh, we're finding by hashes.
Yes.
So then that's stupid because the hashes have to be strings. Oh man. Or we have to convert it.
We're
Man,
gonna have
let's
to
make a
convert it.
structure later that abstracts this hash array garbage.
Okay.
Oh man, can you pick this up and lose my voice? Yeah.
I can actually.
Let
But
me
we're gonna have
commit
to.
this.
Oh man, but we're gonna have to combine the recordings. That's so painful. I don't want to do that.
Oh, I can continue recording. I can just change the screen.
Oh, sure then. That works.
Let me go Emacs because I only know how to use Git on Emacs, and I'm proud of that.
Jeez. So which branch are we in?
I know master and committee. Just a sec. No. Branch starting at here and bookkeeper.
Oh, you're gonna start a new branch?
Yeah, commit.
Sure.
I think I'm actually going to leave a little earlier today.
Sure.
Oh, so we can stop now then.
Yeah, I think it's already like 10:30.
Yeah, we have plenty of recording as well, buddy.
Okay.
Oh, actually 1 hour and 31, but we are here for
That's
more
awesome.
for
That's
longer
enough. That's
than
more
that.
than enough.
Okay, so the code is up. You guys can check. It's called Bookkeeper, the branch.
Okay.
Alright, folks, so that's it. Ending the recording, and it was a pleasure to do it today. And next session, what is the plan? It is
Well,
to have
at least the
networking.
intention is we're gonna have, and this time for real though. Let's try to make this for real, like seriously. Let's read the documentation from the distributed file system that Breno shared.
Well,
Let's read the
I prefer to
cluster.
actually read the one from the GNU one. I think that's more
Sure.
that's close, more relatable to what we're doing.
Okay, so let's read the cluster link that Magita shared. And then next time, what we're gonna do, we're gonna make the API for the bookkeeper because some program, which is gonna be this, what we're gonna run as the main entry point, we'll call the bookkeeper stuff and we'll run a server thingy. And we'll have to interact with like doing lookups in the files map, doing lookups in the hashes map, changing the Merkle tree, all that stuff. So probably that's what we're gonna be doing next time.
Okay, that sounds good to me.
Okay.
Alright, so see you everyone.
So,
Bye, future people.